whereas our FameLab Netherlands champion, Marcia Brandenburg-Goddard, was born in Amsterdam, which is slightly closer. So Marcia may be surprised she's the nearest thing we've got to a local in tonight's final. Now, if you're going to be rooting for Marcia, you might want to know she's a PhD student in clinical neuroscience at Leiden University and describes herself as a passionate Dutch Trinidadian brain junkie who also loves riding horses Western style and fancies herself quite the cowgirl. So saddle up, shout yourselves hoarse, and go wild, wild west for our Leiden leading lady, Netherlands FameLab champion and local favourite, Marcia Brandenburg-Goddard.
If you're happy and you know it, clap your hands. If you're happy and you know it, clap your hands. If you're happy and you know it, then your face will surely show it. If you're happy and you know it, clap your hands. Awesome. This is just a silly kid song. And it's probably not very hard for you to determine if I should clap my hands or not. Should I clap my hands if I look like this? As easy as it may be for you to decide if I look happy or, well, pissed off, figuring out people's facial expressions can be a daunting task for people with autism. Neuroscientific research has shown that this problem might have something to do with the architecture of their brains. Think of it as a highway interchange. A typically developing brain is like a very efficient interchange. Information about facial expressions merges into neural traffic, and it takes the shortest route to the exit with the appropriate emotional label. Happy, sad, angry. The autistic brain, however, is tangled. It's a much more complicated interchange, full of roadblocks and dead ends. Information about facial expressions merges into neural traffic, but it gets lost. It goes left, it goes right, it turns around, it tries again. But it often ends up stranded without gas on the emergency lane, which can lead to these problems. Without treatment, that is. You see, people with autism are not crazy, and they're not dumb. They're just wired differently, and we might be able to use that knowledge to our advantage in treating these problems. Our research has shown, for example, that a subgroup of kids with autism use the frontal parts of their brains to label facial expressions, while other kids with autism do not. Even though they both have difficulties labeling facial expressions and they both have autism, these two groups take very different routes on the neural highway towards those issues. Now, if we can use this knowledge, then we might be able to create treatment that is tailored to these individual differences in the brain's road network. For example, we can use exciting new techniques in brain scanning to train them to use more of the brain regions you and I use when we label facial expressions to see if it improves their skills. But whatever the method, individualized treatment might make it possible for us to create custom-made neural navigation systems that will allow people with autism to confidently tell you that you look so happy right now, you should definitely clap your hands.
Always a clever trick to work applauding into your routine in case nobody wants to clap. But
it's claptrap.
It's claptrap, yes. Well, I wasn't saying to talk claptrap.
Can you explain to us what stage this research is at? Is it being applied to real patients or not?
I was actually talking about my own research. So,
right.
Yeah. Yeah, and the training that I was talking about, that is sort of an implication of my research. I've mapped the brain of different groups of kids with autism, and what I want to do next is use brain scanning to train them to influence their own brain activation to see if the symptoms get better.
And when would that, in practical terms, be able to be used on patients? What?
It's already possible, I just don't have the money.
Oh, I see, right, okay. Okay.
You were mentioning, sorry, I have to ask a question because I was a little bit, I misunderstood it. When you're talking about two subgroups having different pathways, doesn't that overly complicate everything? That you would want everything to go in one direction, maybe? How do you deal with the fact that you were inferring two different pathways? So how do you break that down, and how does that help you when you're starting to find the pathway that will help everyone? But is that, well, I'll let you.
Well, the thing is, there are different pathways to the same behavioral symptoms. Right. That is basically what I'm saying. These kids have the same behavioral symptoms, but the route to those symptoms is different in the brain. Okay. And if I want to influence brain activation, I need to know which brain areas to target, and that's why I did this research.
Okay, okay.
What made you want to communicate this to the general public?
2 reasons, actually. One, I think it's incredibly fascinating. The entire brain is incredibly fascinating. But the main thing is, I work with clinical groups. I work with kids with autism. And I want to help them. And in order to help them, they need to know what I'm doing. And I think the best example I can give you is that I did the preliminary heat in the Netherlands. And it was broadcast on TV, the national finals, actually. And I got an email from a kid who said, I have a boy with autism in my class at school. And I understand him better now, so thank you. So that, for me, is the best prize I can get. So that's why I'm doing it.
And so where do you plan to give this talk next time?
Anybody? Whoever will have me. I will do it whenever and wherever I can.
Okay, thank you.
That's the way to be a science community. Clap happily, please, one more time for our almost homegrown Marcia Brandenburg-Goddard.